Great. Great. Let's get started. TMA. What's that?
I think it was a minute.
Ah, okay.
Yeah, wait for a second.
Okay, we'll wait for a minute. So, for those of you in internet land, what's going on right now is we're getting food here at Meta, thanks to Jane of Zencash.
Yep.
And we'll kind of get started in a moment. Up here, if you want to follow along online or in the archive, we've provisioned a special domain name for the occasion, Zendentity.com, for the princely sum of $8.75. Okay. What do you think? Should we?
Let's wait on them.
Wait a minute.
Yeah.
Wait a bit more. So I'm going to. There
Oh,
we
show
go.
the hacking.
Yes. Oh, one thing is so the HackMD notes are showing now. So let me show you how to do not screen share your whole thing, but screen share this one. So if you go back to the Hangout, please. Or actually, can you go back to the, this one here? The I think the other screen. So delink this tab so it's a standalone
No
browser.
croutons?
Yeah, perfect. Now go to the Hangout.
Oh, I want all these though.
Yep, but we'll just keep these two separate ones so that when you're taking notes and stuff.
What are you gonna do?
You know what I mean?
Yeah.
Is that okay?
Here?
Yes, and now go to the screen share.
Yep.
Select. Try again. And then select the application window.
We need
that
more
is
chairs.
This one.
Yeah.
Say share. Okay, now you can open up. Now you can go to HackMD and we'll
And
select
the other
this.
one. Okay, can I put all three tabs on here and I'll just share the ones that I want?
Sure.
Okay, cool.
So you can open a second tab.
There.
Perfect.
This one doesn't work, so I'm just gonna do the thing.
Oh, I can fix it. What did I do wrong?
I don't know what's wrong with it. And I
SRC equals.
I tried the code, it looked all right.
Here,
But here, I have it right here. It has it. So I can try it. That's all you had on your page anyway.
All right. I'll put a direct link on as well.
Okay.
Oh wait, that's not the right link. Here's the direct link.
The hacking is just practical.
Totally okay. Zendentity. Sale of goods. Sale of goods. Oh, I see the issue. Yes.
Thank you so much.
All right, it should work now. Zendentity. I think it just didn't update. We'll update any moment. Ah, there we go. Ta-da! Da-da-da-da.
Oh, sorry.
You have the most stickers on your computer that I've ever seen.
If we did some archival layers, you'd see some really great projects from yesteryear. Okay. Great. Okay, great. Well, so let's get started. Dylan, do you wanna kick us off?
Sure. Hi everyone, my name is TMA. Welcome. So today we're going to explore how innovative fintechs, products, services, and markets are arising from new digital assets such as identity and data. So to get us started, Daz is going to go over a brief overview of the concepts and the terms that we'll be using during the course, and then he'll dive into a scenario on a sale of goods to explore how to identify the actors, actions, and data for each scenario so that we can expand on these concepts and understand the foundations of how to dissect the scenarios. And then I'll go into a more complex scenario that we dived into during the inaugural computational law course at the MIT Media Lab, where Michael Casey was exploring how to use microgrids in Puerto Rico. So we'll use the foundation set up by DAZA to go and look into that particular initiative. So to get us started, DAZA is going to start us off. Yeah.
Okay, thanks, Tammy. So this description will set some context for how we're going to get into the topics, but I just want to start by acknowledging and thanking Jane and Zencash for helping put this together so we could meet everybody. And we really do want to meet everybody. So this has been set up as a very interactive kind of workshop. So I will set some context, but we'll be seeking to elicit views and ideas, questions from everybody. Okay, and as I mentioned, just to be sure everyone's aware and is comfortable with it, we're recording, I think the venue's recording, and then we also have this recording that's going to the law.MIT.edu YouTube channel so that we can bring some of the learning back home. Is that okay? Yeah. All right. So let's face it, our digital identities and personal data have become an important economic and practical resource and of increasing value. The personal identity of individuals involves more than money because there's civil liberties aspects, there's social aspects, it's almost philosophical what our identity is. But we're very aware that the context for this lunch and so much of what's happening this week here in Hong Kong revolves around economic questions and financial questions. And that is very much a part of identity as well. You could look at online identity or digital identity as an emerging asset class. It's a digital type of asset. Same with personal data. There are thriving industries that exist to collect, track, and trade this information, but business and legal models regarding the rights and expectations of parties utilizing digital identity are still emerging. Let's just say it's still relatively early days. And in a sense, the business models and certainly the legal models have not evolved to keep pace with what's happening technically. The technical capabilities have outpaced business and legal models. Okay. So the rise of smart phones, smart homes, and smart cities, among other, smart objects and Internet of Things, accelerated by blockchain and smart contracts and mass automation in general, offer new modes for control, new methods for valuation, and new mechanisms for exchange of the key rights to this new asset type. So let me just break that down a little bit because there's a lot of words there. But when I say rights to the asset type, I'm thinking like the first year in law school, one of the things that people learn is ownership is not really a monolithic thing. You could think of it more like a bundle of rights. The right to exclude others, the right to rent or lease or license, a right to destroy an object. These are all examples of ownership rights. There are more subtle rights that emerge with some of the blockchain-enabled and smart contract capabilities that source and use identities, such as a right to access and triggers for things like like turning on and off services based upon preset conditions. There's a number of rights that people have. So we will catalyze and focus discussion around an applied identity anchor scenario. Actually, two of them. I'll start with one anchor scenario, and then we'll go to a more complex one that we want to dig into. The anchor scenario that I'm going to bring up explores the legal validity, admissibility, and enforceability of blockchain-based digital signatures to grant or revoke consent and authorization for electronic transactions. So just to unpack that a little bit so that we're ready to dive in. What I mean by blockchain-based digital signatures, actually, let me just ask, who has an idea of what that could mean? Yes. Oh, can you maybe start with your name?
I'm Leo, one of the founders of Inova Technologies, engineering company in Hong Kong.
Huh.
So blockchain-based digital signature, I would say it's a digital signature using any of the digital signature algorithms that could be verified on a blockchain, sharing the private parts of that.
Very good. For those of you, I've just got one microphone here, so it was basically any digital signature algorithm that's verifiable on a blockchain. That's an elegant way to put it. And so, like the typical digital signature algorithm, for those that aren't steeped in this, would be RSA, the RSA asymmetric curve. The algorithm or the curve, I should say, that's supported on the Bitcoin blockchain and the Ethereum blockchain and many others is an elliptic curve, a little different. It's SECP 256K1 is the curve. So one of the things that we did was we looked at utilizing that curve, the one that's native to Bitcoin and Ethereum blockchain, and as a way to digitally sign off-chain transactions. So basically, we used some wallet technology and some other things to enable a user to access the private key material and to digitally sign PDF documents and JSON data that were that were part of transactions that we postulated in commerce. So the one that we're going to that I'll dig into first, just to kind of set terms of reference and to kind of get conversant in this, will be the simplest transaction we could imagine in commerce, which is a sale of goods. Okay. That brings us to the next sentence. What are the key issues, options, and opportunities for startups generally, and especially for innovative fintech products, services, and markets for this new digital asset class? That's generally the conversation that we would like to have with you. So to show you a little something of what we're talking about, you can see linked to the Eventbrite page. We have, let me get to this. Yeah, I'll share my screen. Yeah, I'll just take it. Thank you, team. There we go. Oh, look, it reverted to the plant. Okay. It's my plant. There we go. All right. This is the same text that you can find on the Eventbrite page. So what we did to test the legal, let's say, status of digital signatures on commercial transactions that source from, let's say, identity on a blockchain, from the address that one automatically creates when generating a key pair and beginning to, basically set up a wallet on a Bitcoin or Ethereum blockchain, was a sale of a used car. The reason we selected that was because we wanted to find something that was slightly above the threshold of, in the US, something we have called small claims court. We wanted to find something that could be an everyday type of transaction that most people can understand and that has got, honestly, centuries of common law and statutes, consumer protection, uniform commercial code around it, and the equivalent in all countries. But that would invoke the rules of evidence and like a proper complete trial, the basically civil procedure, so that we could see, in this case, just one sliver of a technical capability of blockchain as a source of identity and as a source of indicating cryptographically, in a cryptographically verifiable way, that a person has digitally signed something, that they have executed or adopted a valid legal signature on, in this case, a contract for the sale of goods. So for this particular, we did a little mock trial where we kind of got a bill of sale. That was the common form in the state of Massachusetts, and we had an Alice and a Bob, and that played out the transaction, and it went something along the lines of. I'm going to go back to the to our page now. Here we go. Just coming through. Yeah, here we go. Scrolling, good. It went something like this. It's a little small, but you've got Alice. Alice signs a contract. Let's just assume it's a PDF for the moment. Just simple, rudimentary, not too different from what people do every day. But what's different here is instead of using the built-in digital signature or electronic manual signature capability in Adobe Acrobat or Preview on the Mac, she digitally signed the PDF with her private key from using her blockchain address. The payment, in this case, would be in US dollars. So we're just isolating one component here, which is identity and authorization, or you could say assent to a signature, to see whether blockchain as a source of identity is as good as what we otherwise would use, or better, or perhaps if there was some trap for the unwary we were not expecting, and there were some gaps here. So we would say this was a research-related fact-finding investigation or exploration of the technology against legal requirements. Okay, Bob countersigns using his blockchain-based digital signature. Alice pays Bob. Excuse me, Bob pays Alice. Bob is the buyer, and then Alice disappears. So no car is provided to the buyer. Alice, and now we have one more lane in the swim lane diagram, which is Bob sues Alice, and Bob enters the signature into evidence. Okay, I may have munched some of those words, but I think you get it. Like we have a buyer and a seller. The buyer transmits the money. The seller accepts the money. The seller does not transmit the goods. Now what happens? So let's say that, let's just assume that Bob is around, and maybe Bob it hasn't disappeared completely, but did not conduct the transaction. So let's say now we fast forward and it comes like time for the trial. So what we discovered over here is that there are a lot of issues that arose. So as we invited some litigators and some really first-class technologists from Stranger Labs, Christian Smith and others, to set up some code, to set up a wallet, and to make it possible for us to use that wallet to sign transactions. Most of what we did related to mortgage origination and signing a bunch of legal documents for that, but we utilized it for this mock trial on a much simpler kind of one-dimensional transaction. Buy the car, sign the contract. What we discovered is that some of the questions were the parties, among other questions, we discussed whether the parties have access to anybody who is qualified and has standing to lay a foundation for admissibility through firsthand expert testimony. So there comes a question, who is going to let me just ask show of hands. Who's familiar with something called laying a foundation? Okay, so just a quick aside, if something goes wrong in a court of law, when you enter evidence to indicate something like a contract was breached, to bring the evidence basically to enter it into evidence, you have to pass a few tests. One of them is it has to be relevant. Another one is you have to authenticate the evidence. So to authenticate evidence, someone has to lay a foundation. And then there are questions that you might ask. So if it was another commercial transaction, you might get a log file, and you might have someone testify, yes, this is the log of our payment. It hasn't been changed since the date. They might want to say, if you're an attorney asking the witness a question, you might ask, has anyone else had access to the log? You might want to show that they had control. In fact, you do need to show that they had control. And you want to show that specifically right here, we have a little legal memo on it. These are the specific standards. There's 6 basic points. And that this last one was interesting, that the exhibit was properly identified. So what we ended up doing in this case is we decided our best bet with a judge or with a human being would be to print the public key and to print what was your name again? I'm sorry.
Leo.
Leo, to print what Leo was referring to about a digital signature verification tool that basically requires 3 things: a public key, a digital signature, which is a signature block, and the file that was signed. And with those 3 things, you can verify the digital signature. And so what we decided to do is print them. We printed out the PDF, we printed out the verification, and the digital signature block, and we printed out the public key. Something that's a little weird is you need to be in a place where, in essence, the judge probably, as well as both the parties, should have the same, should have access to those 3 files and agreed standards-based verification algorithms or software, and should be able to achieve the same result. When we hash this file, we get a certain message digest. SHA-256 is what we're using. And when we digitally sign this file, we get this signature block. And if that block hasn't changed, we know 2 things. Number 1, the private key associated with the public key was the one that digitally signed the file. And number 2, the file hasn't changed since the time of its signature. Does that make sense so far? Well, it's easy to say that. It was a nightmare trying to play act that in a court of law in a way that people could understand. And I just want to identify that that was something that we didn't see coming. And so what's happening now back in the media lab where we did this at MIT is a small army of user experience experts and litigation experts trying to think what would be the documentary evidence or the ways that one would easily describe and show this mathematical process such that others could understand that wanted to verify the transaction. Another thing is the cryptographic and other verifiable data is correctly aligned to the specific activity and the records necessary to legally attribute the technical signature process to a given legal party. So in other words, this second question was, how do you link the private key with a given party that is accountable or responsible for the transactions that were conducted that they signed? So you can extrapolate this to blockchain and more exotic transactions, but we just want to isolate this identity aspect first. And the pointy end of identity legally is a signature. So there's different ways to do that. I'll just mention one which so far to me seems most promising. And the phrase that we'll use is dual integration. So there's no one way to do this, but the basic concept would be that in a legal document, a human readable document describing a transaction, usually in the top, we have recitations of who the parties are. So maybe like, TMA of 123 Elm Street and DAZA of whatever, 52 Greenwood Street. The parties agreed to the following transaction. You could, in the legal document, include one more identity attribute, one more address, which would be perhaps the public key of the party and the address on the relevant blockchain, where we are leveraging the blockchain-based digital signatures. You could just type it out. You could say comma with the following public key, find about the following address on the following blockchain. And you could do that for both parties. Now, conversely, if you look at the blockchain, you could put in, if it was Bitcoin, for example, op return for a transaction, a URL to that legal document. So we put the legal documents, the PDF, just in GitHub, has a nice URL. So you can put it anywhere you want, but basically we thought a link to the document where you could find the file that was signed, and a hash of the document could be included on a blockchain-based transaction. So what you now have is a pointer or a cross-reference, you could say, of the key relevant data to bind the legal party and a transacting party on a blockchain together to a given transaction. We can call this a design pattern, if you will, and you could implement this any way you like, but this seemed to be a logical and minimally sufficient method to handle the second bullet that came up when we tried to actually test this stuff in a somewhat realistic scenario. Another thing that came up was the purported signatory, in fact, had the requisite legal intent to sign, that is to authenticate, be bound by, assent, attest, consent, etc., authorize the contract or other record in question. So here's an interesting thing in the law. So let's just say Bob, for example, at the opposite buyer. Let's say Alice, the seller, who never delivered the car, was 12 years old at the time of the transaction. Well, under the common law, there's no breach of contract. There's no contract to start with because minors cannot form a contract. Let's say Alice had a gun to her head at the time from Bob's mischievous cousin or something. Well, now we have duress. And so that type of coercion also would be a complete defense, or would be a defense potentially, let's say, to enforcement of the contract because they lack the requisite legal intent to sign. So technically, you could show all day long that the math works and that the signature verifies and validates. But for lots of reasons that we may not want to consider the transaction enforceable, such as these defenses I'm mentioning. So that was a third item that we surfaced when we played through the scenario. And then also the right evidence was created and properly maintained to sufficiently prove a valid chain of custody. That gets into other stuff like supply chain and provenance and things. That's not so much a deal right here, but that can come up in other situations. And actually plenty more hitches and snags that we identified. So I can say, like at a high level, this was a, well, actually I'll just read it. So we expect and hope the above exploratory prototyping will generate constructive and valuable feedback and other inputs to software and tool and practical innovative designs and process builders. So as we discovered these things just by playing through the scenario, one way to look at that isn't, oh no, like it doesn't, there's issues, but oh goody, there's things that we can build. We now have a few more requirements that can be solved. We have legal use cases that can be solved by structuring and engineering, shall we say, the transactions to address them, to manage the risk, to create and preserve the evidence that you would need to avoid these problems. These are foreseeable issues. These are not the issue sets that usually come up at meetings in startups and in big companies and government and other places where where it's the CIO or CTO driven processes or even business driven processes because they're legal. But we're trying out a new method of co-design, which is to surface business, legal, and technical requirements as part of a holistic set of design requirements and constraints, so that we can basically not find out later that something wasn't working, but also to be able to take not just like these kind of heavy requirements from law, especially in the ICO space and in other regulated industries. A lot of the legal requirements seem quite onerous and just an unfortunate thing that happened to you that you have to deal with one way or another or avoid. In some case, like in contract law, for example, and identity law broadly construed, there's a lot of wisdom in the law. Like you don't necessarily want contracts that are easy to have coercion or fraud or forgery on, right? So there's some of these kinds of defenses and other legal requirements actually have a lot of common sense. And by playing out these types of scenarios at law.MIT.edu, we're hoping to take an engineering approach to a more holistic design and build and deploy process. Okay. So this is literally a process of evidence-based requirements gathering. In this case, it was the law of evidence that we use, but there's lots of interesting other areas of law. Tort, property law is the big one that we're going to tackle in 2018 back at MIT, well, there's so many. Agency would be the other one I would just highlight. Who here sort of knows the law of agency? Agent, principal, third party. Yeah. Do you have a legal background? I do. Yeah. Great. I'm just going to say, I think this is probably one we could get billions of dollars of mileage out of, looking at everything from OAuth to authorization flows to more exotic blockchain-based transactions. There's very sensible, centuries-old wisdom in the laws of agency and when a third party should be held, should be able to be basically accept the gains when they've reasonably relied upon, for example, of what an agent of a principal has done. We even call so much software an agent now. Who's the legal party behind these agents? And what are the fair allocations of risk and liability in the new formations of roles and relationships and transactional flows with this technology? We think we can actually surface some very, very powerful and very helpful solution-oriented requirements from the law of agency, among others, contract law as well. Okay, let me speed this up a lot. What else was I supposed to say?
That was it.
Okay.
You wanted to go over the supply chain scenario.
Okay, I'll say one thing on the supply chain. Yes. Oh yeah, could you say your name, please?
I'm Brian.
Hi, Brian.
So I'm trained as a lawyer and now in startups working in fintech and the like.
Awesome.
Electronic signatures have been around for a while. So what has your analysis been vis-a-vis the existing piece of electronic signature legislation? And to what extent are there deficiencies in line with the blockchain?
That is a very good question. Did everybody hear that? Yeah. The question basically was, what about the existing law for electronic signatures? And is that not sufficient to address blockchain-based signatures? So let me just speak to that for a moment, and then maybe we'll do that instead of the supply chain, and then move forward. That's probably a better question. So the fundamental law for electronic signatures can be found in UNCITRAL, Model Law on Electronic Commerce. That's United Nations Commission on International Trade Law.
I actually participated in some of those discussions at the UN way back when.
Way back when, me too. So did you know Tom Smettinghoff? And yeah, right. Those are the days. So the basic you may remember, Brian, right? The basic concept at that point in the late 80s and 90s was to have legislation that, let's say, removed undue obstacles to the use of electronic signatures and electronic records in commerce. This is partly because there is a lot of statutes and regulations and even common law from judicial cases that assumed and I think inadvertently required signed in ink kind of language. Well, that's not going to get you too far. You now have a technical problem when you use an electronic signature and some area of law that covers your transaction that requires something to be signed in ink or written in paper. What they meant would be, signed in a way that you could authenticate the signer and tie them to the thing, or inscribed in a tangible media would have been nice language. But hey, in the 30s, 40s, 50s, they did the best they could. They assumed paper. And I came across a bunch of law in Massachusetts that assumed microfiche and other funny media. So we had these technology-specific formulations of law that this UNCITRAL model law and the implementations by statute in virtually every country now. In the United States, we implemented it in the Uniform Electronic Transactions Act, which I was at every drafting committee meeting of for years other than one. And the federal law is called the Electronic Signatures in Global and National Commerce Act. So I participated very much in the drafting of that in the House and the Senate, and testifying and getting it through. And we basically have achieved this. So what we now have is a formulation of law that avoids the obstacle of a signature being denied legal force or effect on the sole ground that it has been achieved with electronic methods. This is terrific, and that really allowed commerce and civilian government transactions and all sorts of societal beneficial transactions to occur electronically, because they could not be unenforceable on the sole ground that they were electronic. What we didn't do was to go a little bit further and to talk about evidential issues, for example, and to talk about other, let's say, what used to be edge cases and now are gaping holes with respect to the use of algorithmic processes that are given fundamentally agency. Autonomous, automated processes are raising new questions about how to attribute signatures and other legally binding assent to a contract or other transaction to a given legal party. These are addressable, but we didn't do it then, and that was wise. Just a quick story, in '96 or something, I was mistakenly, in retrospect, involved with state legislation, the state of Utah digital signature statute and a few others. And then Malaysia, I think, picked it up in a few other places where we thought, well, we could address this. We'd go, if we went further and actually addressed the use of public key cryptography and concepts such as non-repudiation, which is not a great phrase, in some ways it goes too far, we could be able to identify and allocate liability and responsibility in more detailed ways, because, hey, the math is so great. Why don't we get more certainty in commerce and not leave it so open? Turns out that wasn't a great idea, because as soon as one tries to define roles and relationships, rights and responsibilities based upon technology in a statute, it can raise more questions and introduce more problems than you've solved, because now what I just said a moment ago about the problem with being technology specific in legislation, you've now created again with, just to play it out, at that point, we thought the implementation of legislation, the implementation of public key infrastructure would include a trusted third party known as a certification authority. And we built that into the law because we just assumed that that would be how it would play out. Not so. Like the business models and the evolution of this technology to reflect and support the practices in commerce and industry and of people is much more fluid than even very smart people can ever guess. And to enshrine that in legislation is actually self-defeating. So what we prefer overall is a policy of more open innovation. But then what you lose is the certainty. So in non-common law countries, like in civil law countries that are much more specific with statutes, and they have to take a different approach. We have an approach in common law countries that basically encourages usage of trade and common standards to evolve from the bottom up, and then to be reflected and codified in standard contracts, standard terms, and ultimately in legislation. I would guess, still have a decade to go before the time of innovation, or more, before the innovation has settled to the point where it would be wise, in my opinion, to reflect specific roles and relationships and usages of technology. And so what that means in part, I think, is that there's a need to fill some of the gap that you're asking about, and some of these open questions I identified a moment ago, with not statutory or regulatory guidance, because that's bad, but instead with practices, standards, with basically common approaches that people that are doing commerce and transactions together agree upon. And this can be identified in white papers nowadays, and it could be identified in contracts. It can be identified sometimes in something as lightweight as a shared FAQ that becomes canonical for how people do things. Or in my life, it ends up being like well-worn issues in GitHub, which is sort of describe how we do things, and then eventually it'll get to the documentation, but it never does. And so long as there's some method to communicate for people to agree, we can fill the gap that way. But I think we have a lot more mileage out of just allowing some deliberate ambiguity for a time, and then communicating the goals, and then allowing even more innovation. So there's a healthy tension here as well. So that's a little bit of some homespun kind of ruminations on the question you asked about where's the gap post electronic signature legislation. Okay, so now we're going to have fun. So those are some terms of reference. So just to go over what we just talked about, so what this is here is a swim lane diagram, and sorry. So one of the ways that we want to sort of engage people is by, so first of all, who knows swim lane diagrams? There we go. Yes, engineers. These are terrific, not only when you're trying to engineer a process, but also to do a deeper dive into the legal dimension, along with the business and technical layers of systems that you could build or that you're transacting with. So what we talked about was allocating roles to actors. So in technology, we'd say you've got actors and actions. In the law, that might be parties and transactions. Okay? Or in a business model, it might be a role like buyer, seller, broker, something like that, retailer, reseller, trusted third party, and transactions. What we do here, basically, we have little. So what we did is we kind of identified, to keep it unambiguous, a human party, or it could be a legal corporation like Acme Incorporated or Alice at 123 Elm Street. And then we just have a little parenthesis to, in this case, indicate her business and her legal role, seller and buyer. Okay, seller, buyer. So you can imagine if we were doing unified modeling language, we'd have stick figures and arrows and like circles to describe use cases. It's another perfectly valid way to identify a use case. And the swim lane, though, allows us to look at sequences and to basically keep roles aligned in a swim lane so we can see the interactions between the roles. Turns out, I've discovered over the years that when you're trying to build a system, especially in industry and government, this technical approach to diagramming out interactions for a system is a perfect match for a legal analysis, because what we always want to know are what are the rights and obligations of the parties in the context of a given set of transactions. And so by naming the role, the legal role, the business role, and the technical role, we think that or what we sometimes call BLT, like a BLT sandwich, has 3 layers, but the sum of the parts is like a whole new thing. So if you can just put the little role designations in these scenarios for what you call the roles of these interacting parties, the business role, what would you call the legal role? Is it a licensor and licensee? I don't know. Is it a service provider and a subscriber? Like, these roles tell us a lot about the legal nature of the interaction. Is it a consumer? Is it a high value investor? And the technical roles, which are usually actors and actions kind of stuff. So you have like the user, you've got the service provider. You can imagine the legal roles, the technical roles. We know more or less what we need to know to do a nice analysis of the situation, including to build. So like, you don't have to. There are other dimensions of these people and these interactions. There's a social dimension, there's a political dimension, there's a philosophical dimension, there's a religious, there's all sorts of ways that you could look at it. Let's just say for today, at least, that business, legal, and technical is sufficient to get predictable results from a system that we would use in commerce. So those are some of the rudiments that we have to play with a much more interesting scenario now, not the sale of a good, but a microgrid. Okay, take it away.
Okay, I think
Oh,
I need
what?
to unplug this.
Let's
So I'm gonna show a quick clip from the computational law course that we had at the Media Lab earlier this month, because Michael Casey does a really fantastic job.
It was in mid-January.
Oh, true.
Actually, in the United States, it's still earlier this month, I guess.
Yeah.
It's like, so, sure, what you say stands. I withdraw my objection.
Let me find this time.
Who knows Michael Casey? Anybody? He's one of our heroes. He came by the class that TMA and I collaborated on, and described a very interesting project he has going.
Project Ledger. Power Ledger.
It's not Power Ledger, but it's a microgrid project in Puerto Rico. You guys might know that Puerto Rico had some really awful hurricanes earlier this year, and their entire power infrastructure went down. So we'll play this.
Yes, I'm happy to get some value out of it as well. So basically, what I'm doing is exploring the prospect of the group of students from Sloan, and also from UCS, also from here at Media Lab. The prospect of building a distributed transactive microgrid, a off-grid part of what they're doing, right? So everybody knows that the public utility has been sort of decimated. Actually, it was almost decimated before the hurricane came along because it was bankrupt, and then, or at least technically bankrupt. And then the hurricane came through and just wiped out so much of the infrastructure. So you have these communities around the country who've been out without power for ages for energy, but they also have this very strong emerging belief, or at least desire, to pursue a new path. And there are many of us who believe that the future of energy is a distributed structure, decentralized structure. And there's many arguments for that. One of the strongest, though, was made clear by the hurricane. That is that you get more resiliency, arguably, if you've got multiple nodes of generation. So that if we just knock out one of them, as we did during the hurricane, sort of major transmission lines that they had, then everybody goes down, right? Whereas if you've got sort of multiple locations, lose one, at least you've got another. This is a sort of an architectural design feature of many versions of security now. We're thinking about the same thing with data security, cyber security. So we push control of data out to the edges. Maybe there's less of a honeypot for hackers to enter into. And so now we have a very different way of thinking about security, which is spread it around the distributed. So that's one part of it. But we also think that if we can move generation capacity and, most importantly, pricing power away from these centralized institutions and bring it down to small market groups, then the learning and the data sharing and the information that comes from the community can be that much more powerful. And that maybe there are better decisions that get made around both the generation and use of power, particularly in an IoT coming environment where devices can be programmed to turn on or off depending on what the price is and what other signals they're getting. So right now, a centralized model, typically, it's a sort of a take or pay model where the central utility is just setting the price, right? Well, that's based on a price that's bearing with it all the costs of credit, all the costs of centralized architecture, infrastructure. I would say corruption. I mean, these are all sort of components of what come to the pricing model that you are forced to both pay and to receive if you are generating your own power and selling it back to the grid, or if you are just receiving it. But if we have this, again, this model where multiple nodes can share, and the price is now being set by whatever the local market is, interesting things could emerge out of that. People could decide that, hey, I'm just going to, I think that there's clearly a rising opportunity here because the price of power is growing. There seems to be greater demand for Wi-Fi services. So I'm going to add more capacity and put up a cell tower and build my own, mesh net or something. Or I'm going to put an irrigation system in, so there's a pump I need to do it, so I can add more power for that. Or maybe it's getting too expensive, so I'm going to, figure out how to bring in a more efficient air conditioning system. These decisions we think become more fluid. That's the kind of economic thinking. So we try to think of it not as a microgrid, but rather an economic development platform. The communities now can do this. So
An innovation platform.
Okay. Does everyone know what a microgrid is? Yes? Okay.
Does anyone not know?
Yeah.
Yeah, I'm still hazy, honestly.
Okay.
It's technical.
So a microgrid pretty much is a isolated energy production community. And so one example of a microgrid is LO3's project in Brooklyn. So individuals who are part of microgrid will have solar panels or other kinds of renewable energy resource generators on their properties, and they all feed the energy to each other. So the idea is to have more dynamic energy production, because normally what happens is in a traditional utility, energy is produced by energy generators. It's fed into the megagrid, and then ISO or a distributor will then send out the energy across transmission lines into individual homes. So so I think we should probably plug it into yours.
Oh, sure. Oh, okay. Connection to electricity is so important,
so
you know.
This is, proof. So the idea of the microgrid is that you can increase resiliency with a bunch of smaller microgrids that all tie into megagrid, because they're generating their own energy resources, but then also have access to megagrid to transact. So so during the computational law course, we did a really quick scenario discussion around like who the actors, actions, and data in a microgrid are. So this is a very, very basic swim lane model. So like what we want to do today is, as a group, maybe define more actors, think about how these different actors within this particular microgrid scenario could be expanded upon, and look at it from like the business, legal, and technical dimensions. So I'm gonna actually use the board here.
Perfect.
We have marker. One.
Oh yeah. We have big plans for the whiteboard.
Yeah. This is all very like interactive.
No way.
We'll get them.
Yeah.
We should have planned that.
Thanks. Sorry.
Statement that the microgrid can also feed into the megagrid, which means there is either a government entity or a large-scale contributor or investor who's willing to build the microgrid, and then they're leveraging, on one side, they're leveraging the microgrid to store and retrieve power. On the other end, they can't have too much of the microgrid, because then they can't returns of the megagrid construction.
So usually private entities will fund their own microgrids, and the utility then views that microgrid as just one consumer.
Okay.
So and that's in the United States. Like the regulations differ country from country, which is what makes microgrids so interesting. To be honest, my background, like I understand the United States regulations a little bit more than any of the other countries. Yeah. So we'll be talking about microgrids in the context of the U.S. regulatory environment.
And there's I guess since we're waiting for the whatever the dry erase markers. Actually, can I ask what's your name?
I'm David.
David. So to David's I guess observation and kind of inquiry, and some of what we'd like to explore as a group is cutting this different ways. So let us say that there's a blockchain that is engineered down to the guts, or let's even say distributed ledger, an energy ledger that's part of this microgrid. And let's say it, as TMA was kind of getting at, can meter generation. So one house in a neighborhood, say on this grid, maybe is generating 20 kilowatt hours. Another has better sun or more more infrastructure, is generating twice that. And then they're also consuming. So that can be metered as well. And there may be some smart contracts that can sort out the accounting among them, and can and could even have as Mike was talking about, a business model and legal model that would be expressed technically as a shut-off in the event that one of the parties wasn't paying. So if they don't pay up, this power shuts off.
It's an automatic function.
An automatic function. You could actually compose that as something that's not connected to a megagrid. You could, and then you could say, as a matter of regulation, one of the things we talked about the following day after Michael's kind of scenario when we dug in was models in the U.S. And in other countries. Chris Berendt, who's one of our speakers, introduced us to and kind of mapped out that where the distribution of the power, well, first of all, the infrastructure is all collectively owned by the producers and the users. So you kind of create a 501c something, or create some sort of like organization that is the owner of the infrastructure and the operator of the system. Now what we have is a self-distribution, not a distribution to a consumer, and perhaps, or actually in reality, Chris showed us some projects that he had lawyered that have highly automated contracts, merit rank order systems for what the valuation of per kilowatt hour would be, and some other things like that, but are not directly regulated by a public utilities commission, because there's not a distribution to consumers. So some of what we'd like to tease out is, so you're kind of right where we want to be, which is like, let's see how we could compose the actors and the actions from a business, legal, and technical vantage point to play with optimization of the tools. You're next.
The largest component of what, from the question which I asked, is we're making an assumptive proposition that the future of solar, wind, water, and all of those technologies will be inexpensive enough or reasonable enough that we do not need the macro utility to be developing much of the infrastructure. And then we'll have an overrun of DC racing power that won't just be feeding to a home, but can then be sold back on a microgrid and then to a megagrid if necessary.
I'm a little out of my depth on the energy stuff, but yeah, maybe you can tell us if that's so. I don't. TMA is deeper than me.
That's kind of where I was going is, if we have a megagrid, we're assuming that someone already takes on a larger risk assessment of the fact that we do need a megagrid, because there is, at this point in our technology of power generation, there's not enough to justify the microgrid's operational efficiency. Solar panels haven't dropped down far enough. There are some technologies in water generation technologies that are coming up that are really cool.
Yeah.
But we're not sure that we're there yet, so we're kind of
So
Right.
There are already microgrids that have been developed and it makes sense financially, but like to your point, it's not this like massive movement right now. And that's kind of like the thing that utilities are debating right now. Like, are microgrids going to be, is the world going to be just completely a distributed, like co-generated network of energy, or will it be this like integration of microgrids and megagrids where utilities will still have to invest into transmission lines, etc. So I think that for this example, we're just going to assume that the two microgrids and megagrids still exist, and they'll transact in some sort of capacity, and we can figure that out together as a group.
It might be interesting to play it more than one way and see what are the what part of what we want to ask, and you asked me to remind you, was here's some additional questions. What other capabilities of blockchain and related technologies could you envision as a good fit for the scenario? There may be some capabilities when we're running the systems on blockchain technology that maybe could bend the curve of business models of the past, potentially. So we'd like to explore that.
And
actually, I think this gentleman's next.
Sorry, I'm Billy. I work at Credit Suisse. We actually look at this stuff all the time, and actually, there's a growing consensus that we're going to see large-scale bankruptcies of utilities around the world because of microgrids. So I think it's fine. You basically spot on in his assessment, because basically there's been trillions of dollars of infrastructure that has been built in the world, and that has been predicated on electricity demand growing at GDP plus a small bit. And most of the regulations, the way these companies get paid is they get paid on how much money have you put in, and we'll give you a small incremental dollar on top of the amount of dollars you spend. But the problem is the heaviest users of electricity, i.e. people with big properties and with big land masses, are the ones that move into megagrids, and they're the most price insensitive, right? So they're running the washing machines all hours and TVs, and they don't really care, air conditioning units. So they're coming off grid, and Tesla Powerwall, etc. So they basically are free riding on the rest of society by taking themselves off the grid, but having the option to use the grid when they want it, and that is not sustainable. So what's going to happen is, ultimately, this microgrid scenario, either you nationalize the whole thing and the government basically eats the difference, or you have to have a completely new way of funding infrastructure and paying back the people that put the money in the first place. There's a company called Repower which is about to ICO, which is trying to do exactly that. So they're basically trying to repurpose the way that funding is done for infrastructure projects. They'll say, you build it. So they're saying, you build a project, we'll pre-fund your project, and you sell me the electricity on the blockchain in the RC20 contract in the future. And that way you can solve this dilemma of, I pay for something that nobody's paying for. So it is a problem, and if any of you want to, or any of you own utility shares, you sell them. Absolutely. It's not an official credit comment, but it is.
Are you David, did you say? I think since you invoked David's name, directly, he now has the right of rebuttal or reply. And then you're next.
Like any system, ecosystem is extremely complex. We're talking about individuals investing into technologies that we're unsure of would be the next generation of technology where they might not get the return off of it. So for example, in the United States right now, solar is still being subsidized. But in the process of that subsidization, just as we went back a decade ago, T. Pickens was going to build a solar farm, 4,000 megawatts of power. We need about 150,000 megawatts of power in the United States. And then his entire project was destroyed by fracking and gas. So we could run into situations where individuals, not unlike crypto and blockchain and Bitcoin, where people who don't know what they're doing invest in the technology which they believe will be the next generation of savings and opportunistic their future, that they're going to make millions of dollars and billions of dollars. And we can find out within a short period of time or a long period of time that technology, which is not like the blue energy, which is another energy source, becomes really obsolete within a matter of a short period of time, bankrupting the individuals who created this new microgrid.
Mega risk.
Yeah.
Even for the individuals, where the large scale consumer, where the institution. I'm not saying institutions are smarter. Someone said the other day, I want banking to be decentralized. I want it to be broken up, and I think we should have regulation. So I go to the food industry, and the food industry wants to do the same. They don't want to have to do the same thing. So where do we fall when we're willing to accept large scale risk and small scale risk for the individual within society?
I'd like to just I'm going to take a note.
Yeah.
And then Tim is going to elicit from some of these comments just a scenario that we can play with, an anchored dialogue. But I guess just on the side, I want to put identifying and addressing systemic risk, I think is part of what that is, right? I'll just say systemic risk. Systemic risk.
Well, because both of you guys have fair points. There's a researcher named Sheila Shansi, and he literally goes around and interviews utility executives around the world. And to your point, utilities, they call it the death spiral of utilities. This is like a common problem that's being addressed in the utility world. But at the same time, there's no consensus on a solution. So it's like, do you change the pricing model so that free riders now have to pay to access the grid, or will there be new technologies that have been undiscovered that are going to completely change the utility paradigm? Like, nobody has that answer, which is why it's an interesting problem.
We're asking the utility industry about the utility industry. I work with them, and they have no clue.
They have no clue, but then also you have, but they're also like in the United States, right? We can have these microgrids, but regulations prevent innovation from happening in the space, and we'll explore that actually in the scenario. And so it's like, how do you work within the regulatory environment to onboard technology that actually makes the grid, more resilient, more efficient, transact better?
So Noah had something to say.
Just to add a different perspective, I actually do this. One of my largest clients is a power generator in the U.S.
Perfect.
Very
Within
cool.
the bounds of my multiple NDAs with them.
Okay.
That's good. Sure to understand.
We're simulcasting.
Power in their region is managed by a central organization, and it actually floats. The price is done as a day-ahead forward auction.
What kind of auction?
It's a day-ahead.
Okay, gotcha.
It's a one day-ahead forward, and it's in 24-hourly straight. So today, you have to say from the 4 p.m. hour, I'm offering power at X cents a kilowatt. And then the central utility just fills the demand in order from cheapest to most expensive.
Right.
And there are bounds. The prices can flow within a band, but it's limited. Additionally, you consider power, the location delivery is significant because there's transmission loss in the lines. And there's something called congestion, where if there's too much demand, a physical metal wire can only handle so much power before it's in a sense full. And so if demand is high and something's congested, routing power around may take a longer route and add a marginal component to the price, make it more expensive. So it's actually a very complex formula.
Yeah. So I want to double check that we basically can accrue the value of the last few comments. So can I get your attention one more time, David? Just briefly.
Yeah.
Right? Okay. Well, so I'm going to come to you in a moment and ask you to just encapsulate the nugget that you want us to take away as a group. But what was the nugget that you wanted us to absorb?
The microgrids as a concept is fine on small scale, but the minute it becomes bigger, it's going to be life-threatening to utilities.
And then number two, that big mega grids may themselves have systemic risk of imploding.
Yeah, that's what I'm saying. So the mega grids themselves have systemic risk as a result. So we need to think of a new paradigm for funding or charging people who are owners of microgrids, because the problem with microgrids is that it doesn't take into account the externality that you cause.
Got it. And David, I heard you say a few things. I'm so light in this topic. Could you just encapsulate fundamentally what you want us to draw?
One of them is technological progress. We're unsure of what that will entail. So how long is this disruptive technology or technology going to survive, and that's when we'll see it. Another one is we're placing
timescale.
We're putting in place a mechanism where the individual small investor is making those decisions for the grid, which can actually harm them financially or even destroy the grid.
Right.
If it's done improperly, because someone can make whatever technology is involved in microgrids. So there's a risk of not knowing, building a system that might not work. And that can create rolling groundouts and blackouts. And we're also looking potentially at cities or groups of people who tend to be in areas of concentration. Yet the majority, if we use the US, is not large cities.
Right.
So therefore, we have communities that are already almost bankrupt. And these people don't have the money to build the infrastructure. So what happens if the major utility leaves? And now we're hoping that the microgrid will come up, and then that becomes even more challenging.
So actually, we might just take a note of what the major from Defense Logistics Agency was. So when we went through this, Defense Logistics Agency had 5 lawyers at MIT that were learning with us, and they run a lot of infrastructure. One of the things that she pointed us to was a model of the rural co-ops, basically, in the US. And apparently those have been pretty stale for decades. She was thinking, we might want to resuscitate elements of that for more resilient systems that can roll better with some systemic risks, because they had some risk pools and they had some more sophisticated financing and I guess risk management that she'd identified that we wanted to explore. And actually, we don't have to write that down.
There's one large.
I think we got notes. What is it?
It's called government bank that's involved in financing these certain projects, and that are as co-ops.
Sorry, you want to summarize your point?
Co-bank.
In simple terms, the pricing is significantly more complex than just plugging a microgrid and feeding it back.
Right. Yeah.
In fact, even from a technical component, power in the US runs at 60 hertz, right? 60 cycles per second. And that's partly defined by the rotation of the motors of the generator spinning, and the entire grid is synchronized. And it's often synchronized to other regional control areas and there are borders where they cross. It's a variable process. So simply just having a solar farm and plugging in the solar panel on your roof, it may work for a few people, but it's much harder to shift the economy to a major microgrid system. There's so many other components to the pricing and the controls and maintenance and on and on.
So I think the takeaway here is that this scenario isn't saying we should move over to a fully microgrid, dominated marketplace. It's more saying what would a small economy within a microgrid look like, and how could that system exist in a place like Puerto Rico, or maybe LO3 in Brooklyn, and how Ledger is doing in Australia.
And so we think it'll be a nice canvas to paint on to kind of elicit the interesting ideas and to communicate. So now that we've set the table, let's put food on it.
Well, so I wanted to quickly ask. So there's 2 scenarios we can go through for the microgrid. One in a traditional peer-to-peer scenario where each individual household will have a microgrid on top of it, or we can kind of see like there's people here who have some industry experience. So talking about how a microgrid that's funded by like a larger corporation ties back into a large utility. So is there like a raise of hands, like utility and large microgrid, or individuals transacting with each other? Okay.
I don't understand the question.
Option one, raise your hand.
Okay, so long as people do.
1, 2, 3, 4, 5, 6. Okay. Option two. 1, 2, 3, 4. Okay, option one wins. So we will do this. Okay, so I'm gonna put this no longer existing. I guess
Okay.
ignore that.
Do-do-do-do.
We have, so first we'll define the actors in this scenario. So does anyone want to volunteer? Thinking about like what entities are involved in a scenario where you have a company, utility.
Well, you have consumer of who knows this? People seem to know.
So is this enterprise based now in this
Yeah,
scenario?
Yeah, it's enterprise based.
So you've got the consumer of the energy. You've got the incumbent utility.
Yep.
Then you've got the startup.
Yeah,
in terms of
infrastructure.
the generator.
Generator, yeah.
The individual generator.
It's kind of like generators and consumers, just at different scales, I'm guessing.
Let's find out.
Then
So-
you've got a regulator too.
In the corner. Yep.
When utility is finance, there's some kind of attack.
So someone that's financing it.
Yeah, someone is financing the utility.
So creditor
Finance.
maybe.
Wait, which utility? This utility, like the
Oh, you said financing, so it'd be more like creditor or funder.
Yeah,
That's big. Like a lot of what Michael talks about is that model and how to build that in.
So there already, the funder side of it, there already exists in the States, for example, for co-op electrical grid systems, a company called Cobank that Mary McBride runs, and they do that exactly right now. They create co-ops for communities, they create the grid, they put everything, they build it out, they fund these.
that is all at Cobank?
It's
Go
Cobank.
Co-like
COBANC.
Okay. Okay, cool.
Equipment manufacturers.
Oh yeah. So Michael last summer had a good thing going with General Electric, where they were very much a big part of the equation.
And sometimes they do the equipment financing, right?
Right.
Yeah.
So we can
GPO finance.
Exactly.
so we can go
And
back
then
on
they charge
funds.
maintenance per hour.
Yeah. You bet. And supply, repair, on and on.
It's often at a fixed cost per hour of generator runtime.
Any other parties?
Distribution network, the operator.
So operators, interesting one.
Maybe that's
The grid.
both
No,
of
the
these?
grid itself.
Yeah.
Yeah, the
Yeah.
grid
The pipes.
Yeah, so can I offer a way to do this? One way to do this, and this is where we start getting fancy, is to say, just arbitrarily, if there was an entity that was formed like the co-op, in theory, it could be collaboratively owned by these parties, not necessarily by those parties, but they could have ownership stakes. Not these parties, not these parties. So we could start to represent some of these clusterings maybe with like with bigger, different colored markers, and then play with that, see what happens. That's all I got.
Okay.
Any other, but then you keep saying any other parties, so nothing happens.
Yeah.
Landowners, like you see.
None of these can be potentially the same party.
And then the grid.
The grid.
The grid.
Okay, so that's actually an interesting question. So with the grid, that's a business question. Who owns, like, where is the distinction between the micro, so we'll call this like the micro grid? This one's like
And so who's responsible for maintenance of that grid?
exactly, okay.
It's expensive.
This is the big,
I guess
these are the big questions.
It depends on the country because transmission distribution sometimes split, sometimes they're not.
I have some good arguments with this blue market.
Say what?
You could have some good arguments with this blue market.
Right. Yeah, that's why we wanted to convene this group on this topic today. We have a strong suspicion based on good information that people here have terrific ideas and creative solutions. We would like to surface and elicit those and then put them up in the sunshine and talk about them.
What other business problems do you guys see with the microgrid and the megagrid's interactions?
Who owns the algorithm? Well, there's a current issue, and blockchain would solve this with what they call settlement, which is if I'm producing power and you're consuming it, at the end of the day, my formula and math on what the price should be or what the fees owed are might be different from yours. We're measuring different points, and it's this nebulous floating thing, and it's more accurate. It's really messy.
Settlement is terrific on the blockchain one, especially when you look at the potential. There's some very interesting hacks out of the Digital Currency Initiative where they were doing interesting stuff about the metering of generation and consumption and printing that basically or entering that onto just like a grid-wide, a microgrid-wide blockchain. That, in theory, it might have collapsed several steps and reduced some cost in ways that could even change the economics of it.
And also, I just wanted to point out, some of the like the corporate microgrid owners right now are using merit-based algorithms to kind of decide whether they're going to use the energy that they produce on the microgrid to produce something or to sell it back to the grid. So that's another thing to keep in mind. Like a lot of times, these microgrid generators, they're trying to make arbitrage off of their energy production. So just put that out there.
We're assuming also here microgrids are only generator, not store electricity. Like we're going to move towards distributed storage as well. So we can actually have negative pricing for electricity where they pay you to take it off the grid, especially on like hot, sunny, windy days.
So you're saying that the
well, you should have two distributed generator, and
storage.
Well, that should be storage.
Okay.
So like you can have a battery that you can get paid to fill up.
Exactly.
And that might not be electricity that you've generated, it might be your neighbors or the grid.
Okay. So this is like even so they're buying the utility.
Yeah, they could. Well, the utility pays them.
Yeah.
If you're.
Oh, to store.
Yeah, like let's say you're away for the weekend, it's a sunny day, and the utility wants to store it for use at night. Then they pay you. You're not even there. The battery makes an independent decision that I'm empty. I'm not being used. I can tell my owner's away, so I'll just store the electricity.
So do you see this as like an application for blockchain?
Yeah, because yeah, absolutely, and that couldn't happen without blockchain.
Currency. So as a prompt, Tammy, here are the questions just as a reminder. So we've been really stressing what other actors, and but we could surface a few more. What other actions could occur? Are there other types of actions, other types of transactions? Michael's, a big part of his concept was, could we build more apps and services that would be beneficial? And we haven't talked about this yet, but 5 or 6 years ago, you're next. What's your name again?
I'm Isaac.
Isaac.
Actually, I'm Paul of it.
Oh, okay, we've got to talk. But some 5 or 6 years ago, there was a grad student in the Human Dynamics group at the Media Lab that did an interesting, what we call computational social science project with a grid in a Nordic country to test the use of an app for energy consumption savings. And what we did was use some what we call social physics, basically, to look at when you have teams of people that are playing in a game in return for some, actually, it was very little money that they would get as a pool, reduce their home energy consumption. So we had little meters that the grid permitted data to come from that went to an app through an interface, and the teams could see, like there's a weekly basis or something, how are they doing? And turns out the social pressure of seeing the friends and the workmates and seeing how we're doing and being able to allocate to people in the group who is leaving their lights on and who is not really pulling their weight was tremendously valuable to get the overall energy consumption down dramatically. for these teams that were playing for like peanuts. So there's like not big money that was incentivizing this energy savings. And there's a paper on it I have to find. I want to say it was something like 17% across all of the participants in terms of the overall energy savings. And when they matched it up to, you know, the like the financials and like the deal terms for you know, a huge tax break to get to incentivize that, or a lot more infrastructure to basically make up or better energy, it would have cost a lot of money to achieve that much energy efficiency by other traditional methods. Are there opportunities for other actions that could be achieved through the deployment of an application or a service among the people in the context of the community that could also make a difference, or other actions that would be cool, financial or innovative fintech or other kinds of transactions? What other what other roles of the actors could be useful? So if this is the, let's just say for a moment we just decide to snapshot it here and not surface even more actors. Could some of these actors be crossover artists, basically, and hold more than one role depending on the context, like a storer and a consumer is one that you just surfaced? Could that bend the economics in some way that could allow for breakthrough efficiencies or productivity that could change, you know, the math on the model? Would Ethereum or other cryptocurrencies or distributed ledgers offer a better fit, like proof of stake to proof of validation of transactions is something that people have been talking about here, I think. What other capabilities of blockchain and related technologies could you envision that that could be useful? All of this is moving toward how could one imagine structuring the technology, I would say legal and business models, in ways that legitimately would allow something like in that blue sphere to be non-public utility, not regulated, like such as the self-distribution model I was describing from Chris Barrett. So those are some of the prompts.
I think the obvious one we haven't talked about yet is what interplay does the regulator contribute to this system? So like what are the different incentive mechanisms to achieve optimal outcomes on behalf of either the mega or the microgrids? So like regulator maybe incentivizing funders into the system, or incentivizing consumers, or incentivizing transactions between stores and potential consumers who can't produce their own.
Hypothetical.
Yeah, just like it would be interesting to talk through from everyone's.
One of the key components for a regulator is reliability. And then, you know, when you turn on the light switch, you want your power to turn on and be at the same quality of power always. Stuff doesn't break. One of the key components for regulators is to ensure reliability, both availability of electricity when you want it and the quality of the electricity. It's always the same exact measure, which is that laptop doesn't explode. And the lights are always on, at least in a first country.
Yeah. So
the regulator has a primary role of ensuring things are up to standard.
Did you see something like a smart contract being applicable from the regulator standpoint, or not?
Yeah, the regulator needs to have some teeth to it to be able to enforce reliability and quality.
Did you have
the
a
regulator
opinion? No. Okay. Yeah. I was just looking at your face.
No, like in theory, like smart contracts can handle a lot of cases like this. But from what I'm looking at, like a lot of my sales and mostly in the States, with concepts like this, regulators can't actually apply their inputs in the process. Usually, it's already out in the market, and they figured out like it doesn't work because I think smart contracts can only handle part of it.
Got it.
I mean, kind of stepping away from the blockchain component, though, regulators could have a high degree of control over hardware, for example, that determines power output and like kind of like trackers. Yeah, so this would be like kind of a way that they could either subsidize or
subsidize.
Yeah,
that's a good one too. And I just added, just based on experience, waivers, exemptions, like there's lots of little things they can do in innovation zones or what have you.
There's potentially something interesting going on between the regulator and what is asked of the regulator and how microgrids are defined. Defined, I mean, in the sense that, you know, is it always going to be the case that a microgrid will be defined by geographical area? Or could it be defined by certain types of people of a specific political persuasion wanting to generate and send power to other people of that same persuasion, unhinged from any geographic bound? And if we do that, like maybe that starts to lessen the load on
Yeah.
Maybe.
You can
So the
imagine a
primary-
federation of collectives potentially.
Yeah.
And some like rural subsidy.
And the
Sorry,
primary context would be the human system that they all play a part in, not necessarily their geographic location.
Okay, are there any more ideas for actions? Other technologies? Yeah.
I was thinking about whether the company should take some security or collateral from building or financing the construction.
We're about to get to energy package tokens, by the way.
Alternatively, whether
This is where
ICO
it's heading.
will apply in order to finance such kind of building.
Securities. So could those possibly be encapsulated in, I don't know, a token?
Somewhere in the
I mean, because when
Good idea.
banks or someone actually finance this kind of microgrid, they like some sure.
Right. Some collateral,
Yeah, some collateral.
secured.
How can that be actually applied to, cryptographic?
Yeah, like a tokenized energy.
Yeah, because that's more
Tokenized
of
energy.
rights instead of
Yeah.
federal rights.
Yeah.
Sounds like a good legal hacker project.
Yeah, so the funder creates a utility token that then the microgrid uses to transact.
Yeah.
Then it's
Potentially.
Or-
It may happen as an ICO for real utility token.
Yeah, or it's created by the consumer, but it's backed by energy.
Or created by consumer. Yeah, so these could come from different
Different stakeholders could create it, but
Stakeholders.
regardless of who really creates it, it's like who has power within the system.
And how could that be encapsulated and reflected and supported within a system that we could design
Mhm.
that would be more economically efficient?
Mhm.
Lots of ways.
Yeah. Okay, I think this is a good ending point. So the point of this is kind of just to highlight
On this
all the
part,
different
on this
business scenarios that a microgrid elicits, right? When we're thinking about like the business, legal, technical dimensions, and then from here you can extrapolate maybe like new ideas that can like I don't know, create the spark for the new business. Like right now there's companies like LO3, Power Ledger, Singularity in Austria. And they're all exploring aspects of this, but no one's really quite figured out like a solution yet. So these are really awesome ideas. So good job, everyone.
Yep, here. Good. So now we come to the oh yeah, yes, Dan. Now we come to so basically what we just did was a very, very, very quick squib of a kind of a modeling exercise that Isaac was mentioning a group called Legal Hackers. It was called space Legal Hackers, not illegal hackers. I didn't realize I blurred my words together there. That is who here is sort of legal hackers? Oh, so those of you that didn't raise your hands are in for a treat. Legal Hackers. Ta-da. Da-da-da-da. There we go. Is an international organization that TMA and I are both members of, and we've got chapters all over the world. Oh, absolutely. Legal Hackers is a fast-growing global movement of individuals passionate about developing creative solutions to some of the most pressing issues at the intersection of law and technology. That's fundamentally it. We have a mission statement as well. Basically, it's mostly attorneys, not exclusively, who are also, you could say, hackers or use rapid development techniques in the modern web and now blockchain stack. We get together on off hours in this voluntary association, and we'll talk about issues. But a lot of us will have some stickers here. We'll get together on an odd meetup, and we'll actually do a rapid prototype of something just to try it out. That mock trial I mentioned was actually, it was held at MIT, but it was a Legal Hackers event, and we got access to a lot of interesting people that wanted to share ideas and learn together. We've got a lot of chapters all in Europe, some in Africa. What's this? Hong Kong Legal Hackers? Australia, Latin America, and this is an actually dated list. We're already growing. Every August, we all get together in Brooklyn, the origin point of Legal Hackers, and that's terrific. What we wanted to tell you about and to invite you to is the Computational Law and Blockchain Festival. We decided not to do a blockchain this time, excuse me, not to do a hackathon this time, because So a lot of hackathons. A lot of us like hackathons, but we wanted to try a different type of event across the world that's more community building, and that focuses not just on, sort of like the power, like 24-hour Red Bull laden hack, but something where there's a learning track. So we'll have lots of tutorials and lots of knowledge sharing from across the world. A hacking track, which I'll definitely be doing that, which is the typical hackathon thing where we build something, and a discussion track. We've got 20 policy and legal oriented discussions that will be convened across the world in very interesting ways. So we, Jim and I will be helping to hold down the Cambridge, Massachusetts venue of this weekend in March 16, 17, and 18. And
Brian, Isaac, David, Donald, and I will be working on the Hong Kong node.
Woohoo!
And hopefully more of you guys.
And hopefully more people.
And hopefully more. And so, if anyone is interested in hosting a node, or if you're in a place that doesn't have a node and you'd like to host one, or if you're in a place that has a node and you'd like to go to it, we strongly encourage you to do that. And we'll have an opportunity to build together and to raise everybody's vote in a sort of voluntary creative community. So, legal hackers, computational law, and blockchain festival. All right. Do you want to bring us home, Tammy?
Just want to thank everyone for amazing participation, and yeah, if there's any questions, reach out to us, and we're constantly trying to think of new projects to work on and developing ideas. So yeah, looking forward to having you guys.
Should we invite people to the?
Oh yeah. If you guys, we're here in town for a couple more days, and we're thinking of hosting people at our hotel this evening. So if you guys are free from 5 to 7. It's called Ovalo
no.
Every time.
Ovalo Noho. We'll be in the lobby reception area. They have a happy hour then. So yeah, we're happy to continue the discussion.
It'll be festive.
Yeah. So yeah, come if you guys are free.
Oh, can you maybe dive into a little more what kind of stakeholders you'd be looking at to engage with the festival, the Legal Hackers Festival?
Right. There's probably at least 3 major kinds. One kind would be people that have a challenge. So if there's folks that have an interesting business model, but they're not sure about the legal issues, or there's a legal challenge, they may have counsel. This is not like free legal advice specifically, but there may be some systemic issue where a lot of creative people looking at, for example, structuring in a certain context, collective that maybe would be legitimately outside the scope of a consumer distribution of power for microgrid, or innovative ways to do computational contracts, or anything. The Evidence Act, I think people will be doing. You can pose a challenge, and then teams can come together to try to, to try to basically develop a project that solves that legal use case or that challenge. And so the people that are posing the challenges will get a little form that you can fill out, and you'd be responsible for adjudicating who the winners are, describing criteria. We've got 5 or 6 challenges already, including lots of them. The other type are people that are participants. And so people that are hackers or developers, attorneys, business people, others are welcome to come and to learn together, to build together, and to converse together, and then to party together, I think. And then the final one would be, I'd say, sort of local community. And so we've got one of the best things about these events is when the sort of local merchants, maybe local law schools, local government, people that are interested in this stuff come, and it's a very neutral, safe sort of place for people to let their hair down and talk in a very informal way. So we get a lot of we get judges and politicians and captains of industry and people that are fundamentally invisible in the middle of huge enterprises. But we were very curious about things, and you can kind of come out of the box and play together. So those are some of the stakeholders.
And I just wanted to add, if anyone's interested in our energy future, I think energy and microgrids are going to be one of the topics for the
one of the challenges.
Yeah, one of the challenges. So we can continue hacking on this and actually think of a more robust solution.
Right. Yeah, and perhaps Michael Casey can take one of those solutions and start to deploy it, or elements of it, in Puerto Rico, where they've got a series of schools and other sites, and they've got very credible team of MIT students and other collaborators and partners. And there is a legal layer that needs to be engineered, not merely lawyered, but engineered in the MIT way. And so yeah, join us. Let's hack together. Let's hack the law. Okay.
Thank
Great.
you.
Thanks, guys.